So what we discussed in the last class? Anybody in the class? What did we discuss? We in fact, yeah.
Robot technology, sir, and what are we dealing with dealing with robots in industries, and what are the
Yeah.
types of robots and applications of robots?
Okay. So basically, we discussed something related to uh, what is kinematics. What we are going to study in this subject. Okay, kinematics, dynamics, control. Okay. So I said these three are the key components that we are going to learn in this subject. 2 units. This is 1 unit. This is 1 unit. So that's more kind of something. But you need to be aware that kinematics and dynamics itself is a big domain. Okay, very big domain. Dynamics particularly. So we'll be covering some of the basics in this course, but it's going to be more like, as I have said earlier, it's going to be more like a lifelong learning. There are a lot of things to be covered. Okay, so that we need to learn. So it's a big ocean area, dynamics itself. Particularly, you would have heard of dynamics in the sense linear systems dynamics. Linear systems dynamics. Whether my voice is audible?
Yes, sir.
Is it comfortable with my voice?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
My wife, in fact, switched on the washing machine. That's the one problem I'm facing right now. Is affecting your rhythm?
No, sir.
Can I ask her to switch off? No, yeah.
No, sir.
Fine. So the linear system dynamics is something we should you would have got introduced to at your undergrad level. Okay? Particularly LTI systems. Okay. But when it comes to modern day robotics, okay? Modern day robotics, we'll be mostly dealing with non-linear control theory, particularly at research level. Non-linear systems and dynamics. So when you are talking about the models that we are going to learn under the third unit, it's more kind of Euler-Lagrange models. Euler-Lagrange and Newton-Euler method. Two methods. We'll be talking about some elements of nonlinearity, but not to the full level. Okay, so I'll be giving you some glimpses of the nonlinear technologies. But you'll be learning one full subject on nonlinear control theory as an elective, okay, in the third semester. Okay, third semester. Completely about a nonlinear control theory. Nonlinear dynamics and control. So this semester, whatever you are going to learn is more of LTI systems and the corresponding control theory. But many of these ideas can be extended to the nonlinear control theory with a little bit of approximations. Okay, particularly a very famous technique, you know that, Taylor series. So you can linearize nonlinear models over a particular operating zone. So we'll be talking about technologies like that, linearizing nonlinear models and then applying some of the linear control tools. Okay, the tools related to linear control. We'll be applying that. Okay, that is something we should think of. Okay. So I would like to give you a brief idea about the entire structure of this program for another 15 minutes maybe. Then we'll get into the subject. Okay. So the structure of this program is more like this. The curriculum is framed more like this. So you have components related to computer science. Okay. And you have components related to mechanical aspect. And you have components related to control theory. Okay, control, signal processing. So you should be very careful. Okay, so when you are going to put your effort, okay, gradually in the first year is a good period for you. So you'll be learning the first semester, you'll be learning subjects like kinematics and dynamics of robots. It's more related to mechanical aspects. Okay. So when it comes to control theory, you'll be learning one control subject. Professor SV is handling that is Venkatesh. Okay. Then when it comes to computer science, okay, you have AI and reasoning. And then you have something related to what is the other subject? Are you learning one more subject now? What is that?
Python for data science, sir.
That's something like probability and statistics for Python. So this is coming under mathematics. Okay. So AI and reasoning is coming under the computer science department. So in the next semester, when you are going to learn, it's more like a navigation. So it's a combination of these two technologies, mechanical aspect and control. And you'll be learning one subject called machine learning. Okay. For machine learning, you should know about AI and you should also have background on probability statistics. Okay. So you also learn something related to Python. So the Python is coming under computer science. So this Python will be useful for you to develop machine learning codes, AI and reasoning, and probability statistics, the core mathematics. Probability statistics is not only connected to AI machine learning, it's also connected to control and signal processing also. When you are going to deal with something called stochastic control. Stochastic control, estimation ideas, estimation theory, prediction and estimation. For all these, you require mathematics. Okay, so my point is, every subject, you cannot become a master of all. Okay, definitely it's difficult. Master of all is becoming very difficult. So maybe you need to choose your interest gradually, okay, by experimenting. While you are learning, do you feel any kind of comfort in doing that? Okay, identify that first of all. First semester is a good period for you to experiment. Some subjects will attract you. Okay, for example, kinematics, geometry. Okay, for example, those who are good in geometry, they will be interested more in kinematics and dynamics. Okay, some mathematical aspects, linear algebra, mathematics. Okay. This is something you are good at, then it may be useful for you to think about kinematics and dynamics in different fashion. So you have to choose your comfort zone, and accordingly you work on it. Okay? For example, if you are going to be choosing computer science subjects, Python, AI reasoning, machine learning, then you have another subject called deep learning in the third semester. All these are happening domains. Okay? These are all some domains, something really happening. Okay? A lot of applications people are relating to. Particularly when it comes to robot, it enhances visual computing. When you require visual computing, the robot has to perceive the environment. So in order to understand or perceive the environment, the robot employs visual computing. Okay, that's called computer vision, they call it. Okay, so this is one domain you can clearly see. This is all AI related. Okay, AI, reasoning, machine learning, deep learning, visual computing with the robot perception, computer vision. So along with that, if you want to enhance the capacity of the robot, maybe you can go in for natural language processing, NLP, or what do you call digital image processing with what do you call you can have something called digital speech processing. These are all some domains, but you have to understand very clearly that when you talk about machine learning, deep learning, okay, visual computing, computer vision, image processing, they are all one-to-one connected with your signal processing domain also. Okay, this signal processing I mentioned here now. So signal processing plays an important role. Okay, so for particularly machine learning, so you would have heard of machine learning acting like filters. Okay, so you can imagine more like a neuron neural network. Many of you would have learned about neural network. So when you are doing this kind of processing, W1, W2, W3, X1, X2, X3, and then taking the linear combination of it, processing it to a function, taking output, more like adaptive filters. Okay, these are all like adaptive filters. The core idea stems from signal processing. Particularly image processing, deep learning applications of image processing, they are strongly coupled. Okay, image and computer vision with deep learning, one-to-one connected. So, but you are going to apply it for specific robotic application. Okay, then it's more kind of application-oriented kind of work. But this image, computer vision, deep learning can be applied for any kind of images. It can be medical image. Okay, if you are not restricting yourself to only robotic application. Okay, medical images, hyperspectral images for cyclone prediction, agricultural applications. So you can keep this kind of image capturing device in a drone, and you can use the drone for agricultural application. Okay, hyperspectral images you can collect, and you can find out features out of it using deep learning. Okay, all these are happening. These are all happening domain. Medical applications you can use. Okay, robotic surgery. Okay, medical application, wherein use heavily perception. Perception in the sense image-based perception. The robot sense the environment through camera. Okay. So this is something you need to clearly think. So when it comes to control and signal processing also, it's heavily, you've got a lot of subjects related to control and signal processing also. The first semester you are learning one subject, advanced control. Okay. The second subject, seventh semester, you'll be learning something called navigation, autonomous navigation. Okay. You heavily rely on control theory. Okay. So third subject we will be learning something like optimal control. It's an elective will be learned. And you have non-linear control. And estimation theory. Estimation theory is heavily connected to navigation. Okay. You will be estimating the states of the system. Okay. This estimating the states of the system. Okay. You have got a different. You got a reinforcement learning control. In fact, reinforcement learning is one kind of machine learning. Okay, so naturally it is connected to CSE, but we are going to use it for control applications, reinforcement learning and control. Okay. We have so many other kind of subjects related to control theory also. Okay, so for example, you can say subjects like optimal control, I said game theory. Okay. So you got cyber physical systems connected to control theory, path planning and navigation. Okay, these are all something connected. Path planning and navigation. Path planning itself is a big domain. Cyber physical. So control theory also is a big domain. So under the mechanical aspects, you'll be learning about kinematics and dynamics. Then you'll be learning about something like aerial robots, then elective, then multi-robot systems, then underwater vehicles. These are all some subjects. Okay, some more kind of mechanics and dynamics involved. Okay, so you should be careful in choosing your electives, and if you plan for certain specific specialization, for example, control oriented, go in that direction. Okay, thereby you can strengthen your concepts, and you can come up with some good projects which can clearly you can project that. Okay, you project your skill sets. So likewise, computer science related programming skills are essential for all the three domains. You cannot avoid programming. Okay, so there are a lot of tools available for programming. As I mentioned to you, Python is going to rule the world. So for at least for another 10 to 15 years, okay, Python learning is essential. because open source software, everything is available. Okay. So I'll suggest a few good websites, like maybe you can type for this Giraffe Academy. And there is a 4-hour tutorial on Python. You first see that. It's Sunday, 4-hour tutorial on Python. It will give an excellent introduction to Python. The 4-hour tutorial, YouTube it is available. 4-hour tutorial. Okay, 4 hours. You can sit for, you can plan morning 1 hour, afternoon 1 hour, evening 1 hour, night 1 hour. You plan that and finish off this. That will be an excellent opening for you to start the Python course. Okay, 4-hour tutorial. So there is one other thing called Mosh. Just type in Google. Mosh Python learn. This is also quite useful. Okay. Use heavily Google Colab. Okay, I'm not sure. Are you aware of this Google Colab? You guys, how many of you are using the class? Google Colab.
Sir, sir has we have seen that sir has our Python sir has told about it.
Yeah. This is a Python. Just Google Collaboratory. You can go and you can run the code just like that. Okay.
Okay.
So here it's you can just like that. You can run Collaboratory comfortably. You can run your code and you can study things comfortably. Okay, so it's very useful tool. So Google Collaboratory, you heavily employ that. Then also there is something called GitHub. You form a GitHub repository. For your class, maybe you can share information, share code. You can study together, collaborative manner. Together you learn, because you guys are going to be sticking on together for another 4 semesters. So maintain a good rapport with everyone. So 4 semesters jointly learn, because the competition is not among you. Competition is outside. Okay, so naturally try to share your resources, understand, discuss problems, analyze, work in a group mode. That will be quite useful. Okay, work in a team mode. Share resources, share ideas, present among yourselves ideas, develop your skills based on that. Okay, that's important. So you have got the softwares, as I have told you. Python is one. Learn a bit about Linux. It will be quite useful. Okay. Nowadays in Windows environment, it's possible for us to create something called a virtual machine. How many of you are quite comfortable with this virtual machine Linux? This class? Anybody?
Sir, I only heard about it, sir. I never used it.
Okay. What about Jaykumar, Vishal?
Sir, I tried using Mac in my laptop once, sir. Windows.
Same like I did.
VR.
Use.
Yeah, Vishal.
No, sir, I did.
Vishal Kaushik.
Yes, sir. I tried using Mac in my Windows once.
Linux, are you familiar
VMware,
with
sir. Using VMware.
Ubuntu, are you familiar with Vishal?
Sorry, sir.
Vishal, Ubuntu software, Linux. Are you?
I was using VMware, sir.
VMware, okay. You are using,
Sir, Ubuntu. Sir, can I speak? Sorry, sir.
Yeah.
Sorry for interrupting.
Yeah.
In first year of my undergraduate, we have used Linux, sir, for C programming. We used it. Okay, basic C classes.
Vishal Ram?
No, sir, I have used.
Okay. Jaykumar?
No, sir, I didn't.
Okay. I think see, whatever softwares I'm telling, okay, don't get intimidated. I'm not trying to scare you or something. I'm just exposing you so that you can start using it. That's my point. Okay, you can start, and it's going to be a very slow, steady learning. Okay, over the years, you will not become a master of all these software in one day. Remember that always. Don't get frustrated. It's a very important point I'm making it here. Because of the proliferation of information everywhere, because of the internet, we may get frustrated easily. Oh, I'm not unable to learn anything properly. Don't do that. Don't get frustrated. Learn in a very slow, steady manner for years together. See, your plan is not 1 year. For years together is what I'm telling you. It's going to be an independent learning from your end for years together. So Linux is something you cannot avoid in the long run. That's my strong statement. Okay, you cannot avoid it. Open source community is becoming more and more stronger. Okay. So So we need to capture this particular strength for our benefits. Okay, particularly when it comes to robotics, we have a tool called as ROS, Robot Operating System. Okay, it's a very powerful tool, and I've been learning this for some time. Very powerful, a robot operating system. Okay, I will show you the website of it. So this is the one. Okay, robot. Just type in Google or rys.org. Okay, just go through this website. That's an assignment for you today. Just go through this website. Get yourself familiar with all this. Okay, what are all the core components? How they are integrating this? You cannot become a master on this immediately, but it will be very powerful to see. Here, OpenCV is something. It's called open computer vision software. Okay, that they are integrating with robots. Okay, so how we can develop projects using this ROS environment, particularly in an environment called as a player and stage. Maybe you can go to this player project. Okay, it's very useful. Maybe you can think of a project in the final semester using this player project with ROS-based environment. It will be a very good work at a PG level. Okay, it will be respected everywhere. Okay, so maybe think about that. So I'm introducing you this software to start yourself getting familiarized with all these tools gradually in a very steady, slow manner. Okay, every day nibble something. Okay, try to work out one small work of this. There are a lot of GitHub resources. See here, the projects are all in the GitHub, many projects. Maybe you can take a small work and try to run that code, see what you are getting. Okay, the stage simulator. Gradually get yourself completely familiar with this particular technology. Okay, so that's important. So we have got different. Yeah, can somebody summarize what I said right now so far on this?
We have to summarize the structure now, sir.
Yeah. Yes. So if you interact now, I can understand whether you are following or not.
Yes, sir. Sure, sir.
Yeah, even if it is wrong, see, when I ask you to summarize or something, even if it is absolutely wrong, no problem. Okay, we can always very well go back and learn from it.
Okay, sir.
Yeah.
This course it consists of both mechanical and computer science, mathematics, and control signal processing in the first semester. Under mechanical, kinematics and dynamics subject is there, and in control and signal processing, advanced control systems, computer science, Python, artificial intelligence, and reasoning, mathematics, probability, and statistics using R. In second semester, we have machine learning, which is a combination of both probability using statistics and Python, artificial intelligence, and reasoning. These two are very important for machine learning, which will come in the second semester. And navigation, it has a little from mechanical domain and the control and signal processing.
Good.
In the next semester, we will be having deep learning.
As well as computer
vision. As well as computer vision. The software is called NLP and digital image processing and all will be based on that.
Yeah.
And and then there is something called as image plus computer vision and deep learning, where it can be used in robotics. But this is not the only domain. It can also be used in medical industry and agriculture industry, where in agriculture industry drones can be used with this. In robotic surgery, in robotic, with robotic surgery also, this is used. Image and cameras are used, and then. Python, it is you talked about Python, sir. Python is a very good open source language, which will be in industry for more than 10 years from now. And you mentioned some YouTube videos based on Python.
Giraffe Academy is something I was interested
yes, sir.
in.
Giraffe Academy.
Have anybody seen this before? Giraffe Academy? Giraffe Academy? This is very good.
Sir, if I'm not wrong, Giraffe Academy, that free code camp, there is a channel in YouTube. They have hosted this.
Exactly. Yeah, exactly. You are right. Who is it? Vijay Ramarava?
Vijay Gopal, sir.
Yeah, Vijay. Yeah, that's good. That's right. That's really good. Okay, so that's the next one is Google Colab.
Google Colab.
Did a repository, create an account. You can share your information with your friends, and you can discuss frequently, and you can share your Python code, Google Collaboratory code, whatever Jupyter code now. You can share it immediately. You can share in your friend's account, and you can discuss about the project development. You combinedly do projects. Okay, that is another important point I am telling you. Don't work in silos. Okay, work together. Take up one project. All three of you put your effort. Three of you can form a team. You are six members. So three in a group can form together, work together, and they can share your ideas with the other group. And that particular group will work on some other project, and they will share their ideas. Thereby, you work on projects. Okay, this is another one important point I would like to stress here. Whatever you learn, you try to apply it somewhere in a simulation manner. Nowadays, it is feasible. Okay, we've got some powerful simulation tools. So apply it in simulation softwares and develop some good projects. Small projects even. Need not be a very big one or something like that. Okay, develop small projects. Develop your resume based on this project. That will be while you are trying for internships or a research work in some big universities or in another university. This kind of internship and research-based work, they are asking for this kind of small projects. And if you can explain the project clearly, they will immediately take you. Okay, so but this robot operating system is something that's really going to change the scenario. So you can put some effort in learning this also. Put some effort. So one more important point I would like to say, as I said, this is a key point. There is so much to learn, so don't get frustrated. So but my point is, go in a very steady, consistent manner you learn. That's important. Consistent manner. From another 365 days from now, if you could have learned 2 hours per day, some additional software or something, almost some 1,000 hours of learning. Okay, that's good for impressing any big company or research work, research organizations. Okay, it's good work, 1,000 hours. But if you're going to work for 10 hours for 3 days and then stop working for 4 days and again put some 20 hours for 3 days, that's not really going to help. This is not really a good way of doing. You keep this in mind, very, very important. Work in a very systematic, routine way, 2 hours a day, consistently for 1 year, 2 years. 2 years means it's going to come around 1,500 hours of learning. 2 hours if you're going to work. Okay, that will be a good amount of work. But normally you will get distracted, okay, distracted, or completely lose track in between. You should not allow that to happen. Do it in a very professional way for 1,500 hours of learning, 1 or 2 good softwares you learn. That is enough. Okay, you can easily get into a good company or a research organization or any higher studies. Okay, so that's the idea. So now, if you look at this, I mentioned about 2 softwares. One is the Python, another one is the robot operating system based softwares, I said. And then another thing I would like to convey here is for robo analyzer for my subject. This may take around, my point of view, it may take around 6 hours of learning. That's enough. You concentrate on the basic theory part in the class. This practical aspect you can learn in 6 hours. It won't take much. There are some good YouTube videos for it. Okay, maybe 2 hours of learning, 2 to 3 hours of videos. That is enough. Once you learn that, in the afterwards, whatever assignment I give, okay, for my subject, use this software and complete the assignment. It may take hours. Okay, for every assignment, it may take 4 hours. And during Saturdays, Sundays, you can work out. Okay. So once you learn these videos, then tell me. I'll start giving the assignments. So, but theory part is also important. At least I'll have to cover 2 units. Then only assignments will come. Okay. At least I'll be covering at least 1.5 units. Yeah. Somebody?
Sir, this is Vijay, sir.
Yeah.
Sir, this robo analyzer software, after you said on day 1, I visited the website. You said to go check the software about it.
Yeah.
And sir, I am using Mac OS, sir, and that software is supported only on Windows.
Oh, that's a problem.
So can you tell any way, sir, how can I?
No, you cannot overcome it. It's only based on Windows. This is
Yes,
all.
sir.
This is what you visited, na?
Yeah, yes, sir.
You can type to their contact detail. There is a contact. There is about is there. Na? You go there. There will be contact email ID. You can check to it. They contact us. Here it is. Just contact this. Give your name and ask for their suggestion. They may give a suggestion.
Okay, sir.
Okay, because I'm not using Mac, so I
Okay.
don't think I've also seen. Yeah, it is only based on Windows.
Yes, sir. I'll ask and let you know, sir, what
Yeah,
they
see,
will
this is
respond.
this is a command region. You can type native. You
Yes,
give
sir.
your name and all those things.
Yes, sir.
And I think virtual experiments are also there. We can check with it.
Okay.
No, I don't think so. These are some lessons they have made. So there are
Okay,
some
sir.
videos I said, no, that is here. Video reference. It doesn't for totally 8 minutes, 10 minutes, totally it come around 3 hours total, maximum. You can sit and learn, but right now don't do it. Once I cover
Okay,
the
sir.
first unit, once you should know what is the homogeneous transformation, direction cosine method and all this, then maybe you can sit through and complete this assignment in a week and then start working on the assignments. Okay, that will be useful.
Okay, sir.
Robo Analyzer is an important software for our subject. Okay, it's prepared by professors from IIT Delhi. So that I would like to tell now. Okay, that's the Robo Analyzer prepared by a very powerful tool. Okay, I think from your end you can mute Ram. Yeah, some noise I'm hearing. Yeah, Robo Analyzer from IIT Delhi. Okay, S.K. Saha. Professor's name is S.K. Saha. He has written a wonderful book on robotics. You can follow that book for my subject also. Wonderful book. Just type robotics SK Saga, you get the book. I think you have to buy it. It will come around 600 rupees, 500 rupees. Check it out. Okay. It's an excellent book. With Robo Analyzer software, it neatly explained also. Applied for it. Okay. So that is one book I can suggest. That is another book I can suggest for my subject. Trig. Introduction to Robots. Okay. This also you can use. Trig is an Introduction to Robots, an excellent book. And if you can also, you can look into, you can suggest one more book called Niku, Introduction to Robots. Okay? Niku, I think a Japanese name. Craig is good. Okay? Also, you have a very famous person, Peter Koch. Okay? Peter Koch is in fact doing a lot of work in this domain, and he has written a book on this type Peter Koch robotics. You will see some of his videos, excellent videos. Okay? And his book material is fantastic also with MATLAB. Okay, you can use that. So now I'm introducing the third software, it's MATLAB. So I'm telling you all this, don't get, oh, there are too much of information. Don't think like that. I'm just keeping these options open to you. Okay, so that you can gradually start assimilating. Okay, you do not rush through. Take up one project and try to relate MATLAB with that and try to learn. Thereby you can learn things. So MATLAB is another tool you can very well use. Our university is having full licensed version. So maybe you can go to the mathworks.com. This is a website. How many of you are using MATLAB in this class? Anybody? MATLAB?
Yes, sir, I'm
Sir,
using it.
sir, in
Yeah.
UG level I've used.
Yeah. Guru Prasad?
Yes, sir, I also use it, sir.
Priyadarshini?
Sir, I also use.
Are you comfortable? Are you proficient in using MATLAB? How many of you are proficient in using MATLAB? You have to learn. Okay, there are so much to learn. So be very somewhat proficient with MATLAB. That will be adding more value to your skills. Okay. So, so that I would like to suggest. Okay. Particularly MATLAB tools related to robotics, prepared by Peter Koch. Robotic Toolbox. This is something you can think about. Then, yeah, the most important one, which Will be useful, but in the long run only. I won't say immediately. Particularly for navigation purpose, we are going to learn the subject. Those who are interested in navigation, mechanical related aspects, maybe you start using VREP also. Gradually learn VREP. Very powerful simulation. Anybody from the class used this before? VREP?
No, sir.
No, okay.
No, sir.
Okay, maybe you can see this. Here it is. Maybe note down this. It's called Populia Robotics. Okay. So here it's you can directly download from this. Apply the educational one. This is see here. There is something you can downloads are here. Now you just go there. Here there is educational. So you can download this. Populia Sim Edu. Once you download it, it is automatically get installed, and you can start using it immediately. Okay. So but there are some good YouTube support for this particular software. Maybe you can go through that. Okay. So that's also a very good software, simulation purpose, very powerful, and many top industries they are now using. Okay, that is a course in Coursera, okay, given by Frank, Park, and Lynch. It's a specialization course on robotics. Okay, they employ this software, VREP. I recently gone through it. It's very interesting, but little tough. This course is little tough. Okay, you cannot do it immediately. It will take some months for you to assimilate some of the ideas because they use a different robot paradigm, not conventional one, mathematical paradigm. They call it as something called screw and wrench theory. Sorry, twist and wrench theory. Twist and wrench. This is a very different paradigm from the standard textbooks. Whatever we are following now, that is different. Craig, Nico, Saha, they follow different techniques. But this material is something very different. But the course content is, in terms of animations, in terms of what you call visual explanations, is extraordinary. Maybe you can see that if time permits. But don't get confused. This twist and wrench theory we are not going to cover. Okay? It's a little different mathematics. It's coming under a Lie group, LIE group, under the linear algebra techniques. Okay, this Lie group is what they are using, twist and wrench theory. It's a new paradigm. Okay, this is they in fact they are applying it. They are promoting it. This idea. They are promoting this twist and wrench theory for teaching robotics. So maybe after the time permits, if you find some time, maybe you can go through it. But I won't recommend this for this particular course. Okay, for our course, it will be difficult to relate. Okay, what they are teaching and what I am going to teach. It may not be helpful to you. Okay, so then maybe first a few topics will be of some use. Okay, French Park, I'll be using some topics, basic topics. Okay. But those who are interested in what you call building some good projects, okay, in robot domain, particularly computer science related. Okay, computer science related, AI, reasoning, machine learning, deep learning. I want to apply for visual perception, computer vision, for robot application. I want to develop one full-blown out-of-the-world project. Okay, if you are really thinking of it, you can do it. Okay, there are some free courses available in Udacity also. Just type. There is some specialization on robotics software. If you write to them, they will give some concession and scholarships. I think during COVID times it may be free also, but you cannot do it right now because you have to study the basics. Okay, robotics software course will be of some use to you. Maybe you think in the long run. Maybe if you join a research group, if they are sponsoring you, the research group is willing to sponsor you. Maybe you join this kind of courses. That time it will be useful. Or otherwise you can do it by applying for some concession or scholarship by second year, sharing some of the projects what you have done through LinkedIn. I have done this project. I'm interested in learning this. Can you support me right now? Like that, you send a mail to them. Sometimes they may consider and they give concessions. Okay, they reduce the cost drastically. It may come around some 10,000, 20,000 totally. So in that case, it will be useful to you. You can get a certificate from them, and that will be useful to you also. I think in Coursera right now they are giving free all the courses. Just check it. COVID time, COVID-19 time. So under this COVID-19 time, they are giving free of cost all the courses. Maybe you can choose some courses which are relevant. So I would suggest some of the courses which in fact you can do. Okay, something like this. I mentioned about Google Colab, Stage, MathWorks, Robotic Systems Toolbox, ROS. Yeah. Now we have to understand one important point I would like to say is a good thorough mathematical foundation will always help you. So try to do at least in every semester, do one max course on your own, out of interest. That will really help you during your research or during your higher studies or your what do you call any company, any robot-based company. If you're going to join, a good thorough mathematical background will be of some use. The subjects what I would like to suggest is number 1, linear algebra. Okay. Calculus, particularly multivariable calculus will be of use to you. Okay. Probability statistics. And the most important point, optimization. In fact, there is a subject on optimal control. Maybe that will be of use to yours, because reinforcement learning is some domain is really coming up in the robotics field, and that employs heavily optimal control. Okay, optimization. Okay, so these are all the 4 subjects. If you are good in trigonometry, all right. Otherwise, you brush up your trigonometry. Okay. Best source for linear algebra I can suggest is one Professor Strang from MIT Open Course. A very excellent course, out of the world course. It is, nobody can teach like him, in my point of view. Professor Strang is like a god to me. He is my god. Okay. So he is a MIT Open Courseware based course. Okay. There is another course on the same MIT Open Courseware for calculus also. But there are calculus some excellent sources on the website, on the internet. Okay, you can refer to many materials, multivariable calculus also. But MIT Open Courseware is the best. For me, probability in statistics also, I can suggest the best course is in MIT Open Courseware. Cyclicus. I think it's a German. A course on introduction to probability. It's an out of the world course. The best way you will teach. Okay. Maybe you can spend 30 minutes a day on this course, and 30 minutes a day on this course. See, don't go beyond this. Okay, 30 minutes above, what happens? You get frustrated. So my suggestion is learn 15 minutes a day, but do it regularly. That's the point. So if you do it regularly, within a span of 2 months, you'll be completing this course. But if you're going to do it 4 hours a day, then you're going to stop it within 1 week, and you will not go back again. So my suggestion is assimilate all the material in a very slow manner, slow, steady manner. Make it sure that you assimilate it. Assimilate the ideas. So with all the materials available, don't rush through. Do it in a very slow manner. That's my point. Okay. So MIT Open Courseware, Cyclicus. Then here Professor Strang, Introduction to Probability. And Probability Statistics. Okay. For calculus also you can refer to Open Courseware. Okay. And if it is feasible, okay, those who really want to excel in mechanical engineering domain, okay, kinematics and dynamics, navigation, underwater vehicle, dynamics particularly. Okay, so I suggest some basic course on physics also. There is one course on physics 8.001 in MIT Open Courseware. For those who are interested in mechanical, I'm making it very clear. You cannot become a master of all the 3. Okay, those who want to go deeper into any one, mechanical for example, you can refer to 8.001 course, MIT Open Courseware on physics course. It is on classical mechanics. Mechanical. Okay, classical mechanics, you have got both the dynamics also. So that is a course. Once you complete this course, maybe you can refer to MIT OpenCourseWare or Dynamics course also, Introduction to Dynamics. A very big course. It will take a lot of time. But you do it in a very later stage. Okay, if you join a research organization or something, you can do it. Okay, Dynamics. So course name is Dynamics. The big course. MIT OpenCourseWare. So around 40 hours of lecture. That will be useful for you to build robots, for example, design robots or build robots like manipulators. If you want to build it, then it will be useful. Okay, all right. So mathematics is an important idea. Along with what? With mathematics, you need to augment that with basic English language proficiency. Gradually build that also. Because in the future, this is going to play an important role. Learn, if it is possible, LaTeX. Anybody in this class know about this software, LaTeX?
No, sir.
Also,
Yeah, learn this software. Okay, it is for writing papers. Okay, I am expecting you guys to publish at least 2 conference papers before you leave the institution. 2 conference papers that will be adding a huge value. Okay, you present it in IITs. I am expecting only IIT or IIC. Present before professors in IITs and answer their questions. There is a huge possibility that you may get into internship. Easily. By final year, they are going to do 1 full semester project, 6 months. If you can get into IIC, IIT also, it will be add huge value to your profile. Huge value. It will just exponentially increase your strength. Okay. So for that, you should have some background on how to write a good paper using LaTeX software. It's freely available online, and they have something called as a kind of a LaTeX user environment where you can directly type the code. It will help you to build code. So for writings and all. Okay, it's quite useful. English language proficiency, LaTeX, both you concentrate. Particularly academic writing, I call it. This is called academic writing skills. So don't rush through. Learn in a very weekly 1 or 2 hours is spent on it. 1 hour is spent on academic writing. Try to write something, okay, about what you have done, how to present it neatly. Try to write and refer to some good material, online material, how to write and all, and then prepare based on that. Prepare good PPTs, good LaTeX environment. Okay, that is another one thing I would like to suggest. Okay, so that's supposed to, yeah. Apart from this, learn the. Without programming skills, you cannot survive. That also is another important point I'm making. Very. Programming skills are going to be the key. Learn any one language thoroughly. Maybe Python, or it may be MATLAB-based coding, or it may be C or C++. Okay, with some background on OS and all. It may be Linux or ROS, or robot operating systems. Okay? Yeah, coupled together these two. You learn that this course will be a huge success to you. Okay, but everything, lot of things you need to individually you should do. Okay, individually you should have the motivation. Individually you should have the motivation to do. Completing the course with only classroom work, classroom teaching. Okay, it's not an issue at all. Not an issue. Okay, but every class, every subject, when you're going to learn, how you are going to go deeper into it using the online resources, deeper into it. That's the key. Okay, if you can go deeper into some areas, but you cannot go deeper into all the areas. Choose 1 or 2 areas, maybe one area which you feel so comfortable or you're getting attracted towards it. And then start digging deep. That's the idea I'm telling you. So, anything you would like to discuss now? Any clarifications? Yeah, somebody summarize from this point. What is it I said?
Can I say?
Yeah, please.
So you said from the oncoming semesters there is a
Yeah,
subject called navigation, and under
yeah,
navigation we will be having a software called VREP, which is a good tool for simulations,
mm,
for making the simulations.
yeah,
And there are few courses which can help us in learning VREP also. Like Coursera, there is a course by Park and Lynch. Uh,
yeah,
they
yeah,
teach VREP, and they apply twist and wrench theory, which is a completely different paradigm of theory.
mm,
And although it is not useful for the current course, it will be helpful in completing the Coursera course.
yeah.
And
The long run,
there
long run, joining any research institution, it may be useful, definitely. Yeah,
yes,
yeah,
and their method of explaining content and visual ways are very good. And in Audacity also there are robotic software course for which you can apply. You can send a code for concession or scholarship based on our projects, so
yeah,
that they can see our projects and give us some concession.
yeah,
And we need good mathematical foundations, basically in the subject of algebra, linear algebra, calculus, multivariable calculus, probability and statistics, and optimization, in
yeah,
which we have reinforcement, which is a control theory under control theory,
yeah,
should be applied under control theory. And also trigonometry. There are a
mm,
few course suggestions in MIT Open Courseware by, for example, linear algebra. We can consider Professor Strang,
mm,
his lectures on it, uh,
mm.
and for multivariable calculus, we can. Sorry.
Open, MIT open source.
MIT Open Courseware, and then again for probability and statistics, uh, this
Citricus.
statistics.
Citricus. C is silence. Citricus.
Okay, sir. Citligus, and
Introduction
and
to problem.
introduction to probability. But we have to keep in mind that we should not be intimidated by seeing all this information, and go step by step with a proper planning, like around 30 minutes per day for one
Yeah,
particular course.
consistently do it for years together.
Consistently,
You are not
yeah.
going to learn for only one semester or 1 year. Your goal is long term. Okay, so for long run, you should be thorough on this. Then only the career will be all right. Okay, don't stop learning after 1 year. It's going to be a long years of learning. Okay, that's I think. Yeah,
Yes,
yeah.
sir.
Proceed.
And under mechanical, we have to have basic understanding of physics. For that also, there is a course suggestion in MIT Open Courseware, and
8.80.
8.001,
Yeah,
and
801.
class.
10. I think. Check it out.
Yeah, okay, sir.
Yeah,
801 or 10.
yeah. Classical mechanics.
Okay, classical mechanics course. And also in MIT courseware, same a course on dynamics is there, which is
Yeah,
helpful for designing and building robots. If you are
yeah,
interested in designing and building robots, there is a
yeah.
course on that.
That requires what you call a lot of individual effort. Okay, very few experts are there to help you out in that. Okay, so
Okay, sir.
building robots is something. It's a long range plan. So you cannot do it right now immediately. You have to assimilate first dynamics thoroughly, then simulate it first. Simulation maybe you can put together and then you have to design finally. It's a long process,
Okay,
but
sir.
it's a very fruitful and rewarding process in the long run. Yeah,
Yes,
yeah,
sir. And also we need to be good in our English, and particularly if we learn a software called latex, we would be able to write good papers
papers.
which will
Yeah.
showcase our project works, and we can present in IIT conferences or
So keep
ISC
watching for it.
conferences.
Okay, just type in Google and watch. Is there any robotics related conferences coming in IITs? If there is any one conference coming, immediately inform me. We'll work together and publish a paper. Okay, that I'm opening it to. Keep searching in the internet. Whether any IITs they're opening up for any conferences, online based conferences. Nowadays, COVID time online only. Okay. Yeah.
Okay.
Yeah.
And then good programming skills are required, and recommended programming languages are Python, MATLAB, C, C++, and also a good understanding of ROS, Linux, and basic about different operating systems if we know, and about particularly about ROS will be helping us in robotics field.
Mm.
And
Yeah. That's it. So classroom teaching is not, you can pass through. Okay, by listening to classroom teaching, you can easily get through. But if you want to go deeper, you need to individually, you have to put some effort, and should develop a strong attraction towards some subjects, and then develop a passion towards it, and then keep digging. That's the way forward. Okay. So one analogy I can say is, I would to see. In fact, I don't want to get into subject today. Another 4 minutes is there. I will just finish it off with one important analogy, which in fact I've been thinking about for some time. See, here is a very general idea. Okay, look at this timeline. Okay, from 4 lakhs years back, we humans, we came into here, and only by the last 10,000 years or so, okay, 10,000 years or so, we are now gradually, what do you call, in terms of science and technology, we are improving. Can you guess the reason for it? Why only in the last 10 years? Why this period is somewhat idle? Sort of much change. No change, much change. No dramatic change. Only in the 10,000 years, huge changes happened. Can you guess the reason? Anybody? $4 lakhs to 10,000.
Sir, is it because humans have been like from 10,000 years ago, humans have tried to achieve something for betterment of their existing lives, or the need or the thrivingness for that has increased?
Yeah, that's a key point. It's called, you said you have an important term. It's called craving, thriving. Okay, these are all something related to religion. Okay, all major religions, if you look at Christianity, Muslims, or Hinduism, all these religions, in fact, there is an underlying thriving or craving. For all this striving and craving is towards truth. We would like to see the truth as such. So this has really helped us. In fact, if you look at these 10,000 years, there is a huge kind of religious kind of influence. That's what I studied. Religious influence, only in that 10,000 years. What happens here is, human beings, they sense and they act immediately. This is the kind of robots we'll be talking in the first stage. Sense and act robot. Sense and act. It's more kind of deliberate action. Immediate action. No deliberation. Immediate action. It's a very rudimentary kind of a robot. We'll be learning that. The artificial intelligence subject will be learning about. But nowadays we have robots with sensors, and then it plans based on what? Some objective functions, future kind of repercussions, future ramifications. An objective function will be there. You try to use objective function and see whether your plans will work out, and then based on that decision only, it will act on the real. I think human beings in the initial stage, from 4 lakhs years to 10,000 years, we are more like the rudimentary robot. Okay, we sense and act immediately. If food is there, we'll go and grab it. If there is an enemy, we'll go fight immediately. Okay, we'll kill each other. So, but gradually we started thinking in terms of long-term prospect, long-term issues. Okay, I want to see after 2 years what will happen, after 3 years what will happen. That has really helped us, and that has happened primarily because of controlling our emotions. Controlling emotions happening primarily because of religious background, my point of view. Okay, the religion tells you again and again, meditate, sit calmly, don't think too much. All this, why they are saying, they ask us to control our immediate kind of what you call pleasure-seeking attitude. They control us. Once you start controlling, you get better insights about your world, and you start controlling the world. Okay, that's what has happened. Okay? In fact, we are now the masters of this universe to a reasonable extent. Okay, COVID has a little bit shattered, but anyway, we'll find out a vaccine. But two ways of approaching the same problem. One is my point of view for seeking truth you can either travel to spirituality, anyway, spirituality in any path you can follow, or otherwise through science. As a young students, I would suggest you to follow this path for some time at least now. In a very religious pursuit, what do you call evangelical terms they call it, religious pursuit. Follow this domain of robotics, okay, for another 2-3 years. The rewards will be huge. In terms of material prosperity, you will get at the same time a kind of mental satisfaction of knowing some facts and clarity. Without knowing things in the right way, always you'll feel not happy. I think with the clarity, when you learn something, that will give you happiness. With that note, I'll wind up today's class. Okay, put some effort, try to learn things in a right way. Okay, is it all right? You want to comment something on it? No, sir, I don't believe in it. Anything to say like that? I fully agree. Fully, allow people to argue. Okay. All right, I'll wind up today's class. Okay. That's all.
Thank you, sir.
Yeah, we'll see on tomorrow, the 8th.
Okay.
Thank you, sir.
Sure, sir. Thank you.
Yeah,